Let's perform our chi-squared test for independence on our car-collar combination data. For that, we're going to use Enterprise Guide, since we saw that made things much easier than trying to do it by hand in Excel. So I'm back to the process flow for our car-color combination analysis. We need to jump back here to the data, and we're going to create a branch in the process flow from our data. So I'm going to double click on our data here. We get to our data, go into describe, down to table analysis. We want count as our frequency. Exterior and interior are our table variables. Now the first thing Enterprise Guide wants us to create is a summary table. So I like to have interior as the column variable here and exterior as the row. This is just the way that I like to think about it. And then down here in table statistics, we're going to click on chi-squared tests. That's going to give us the test of independence that we're looking for. There's nothing else that we need to look at here, so let's just hit run. Before we look at this, you saw that there was this branch come off the data step, and now we've got this table analysis running, and we can get the output from that. So I double click on that output, and we can look at the output for our table analysis. Okay, first thing to look at is the table at the top here. This table is our two-way summary table. We had 15 black interior, blue exterior cars. Down here, 9 white exterior, grey interior cars. So this should match up with our original data. We can also look at this column percent row for each of these rows. And this is one way that we can immediately look for interaction. These column percentages are for each of the interior colours, what percentage got each exterior colour. So we've got 15% of the black interiors were in blue exterior cars, 48% of the 18% of the black interiors were in red cars, 41% were in silver cars, 25.5% were in white cars. Now if we had no interaction, that is, if we had independence between these colours, we would see these percentages the same across here, but we don't. Instead, we see that for the cream interiors, those were much less likely to be seen in silver cars, more likely to be seen in blue and red cars. Similarly, the grey interiors were more likely to be seen in blue interior cars, less likely to be seen in white exterior cars. This is the same as the second set of pivot charts that we saw earlier. Heading down to our second table here, our second table presents the results of several different chi-squared tests of independence. The one that interests us is the top one. That's going to be typical as we're looking at Enterprise Guide output. Many times it's going to give us more tests than we were anticipating. The top one is almost always going to be the one that we're looking for. So we get a chi-squared test statistic of 18.44. On its own, that doesn't tell us very much. We don't know whether 18.44 is a big enough chi-squared test statistic to reject our null hypothesis. So we jump over to the next column, the prob column. This is the p-value for this test. And so we've got a p-value of 0.0052. That's about 5/1000ths, or about 0.5%. This is then substantially lower than our standard cutoff of 0.05 or 5/100ths or 5%. So we would reject our null hypothesis, conclude that the alternative is likely to be correct. That is, that there is interaction between exterior and interior colour. Or alternatively, that exterior and interior colour are not chosen independently of one another.